Paraconsistent logic. In normal logic, normally, uh, all statements which are both true and false would result in something called explosion, which allows everything to be true, even absurd statements like 1 equals 0. In pair-consistent logic, however, it does not break the entire system. However, it ignores it, unlike Boolean algebra. When graphing trueness, a square will be formed because all graphs will result in a trueness graph of false being the y-axis 0, 1, true being the x-axis 0, 1, 0, and the intersection of those, which is added as a third variable in pair-consistent logic known as both, meaning they intersect at 1 and 1. It is usually at 90 degrees when you form the truth lattice, which is a square, or in most contexts, it's a 45-degree angle, or 0.78539816 radian degree. Additionally, in group theory, square symmetry will all be equal to this. Pair-consistent logic in AI is used to detect errors in users' responses and not create explosions. For example, in this, if the user types in the false statement, "the moon is made of cheese," we can find that this forms a truth lattice, where cheese is most likely to be false and the AI knows the moon is made of rock. We can see that A is the mean of C or B. That means that C is perpendicular and therefore it is orthogonal to B, which can mean that C is not on the same world as the true value of B. Finally, Curry's paradox says that if a sentence is true, then this property is true in all possible worlds. More simply, it states if this can be proven, XXX is true. You can prove that Santa is real using this. However, this can be proven false if you compare, because A and P will always be parallel if you draw straight lines. AP and B are parallel. Interestingly, this contains paraquantum logic, which deals with orthogonality, which we mentioned on a previous slide.